this video we are going to solve the previous year questions that has been asked in electrocyclic reactions. Okay, electrocyclic reactions and homo-LUMO concept. So if you haven't watched the previous video, then kindly watch the video, then only you can understand the concepts. Okay, so first of all, what is the question is, according to FMO approach, HOMO of hexatriene in the following reaction. So they are asking the nodes. Okay, among these, what is the correct node? First of all, you must understand that what is the HOMO of hexatriene in photochemical condition. Okay, they have given that photochemical condition. So read the question properly in thermal or photochemical. Here it is photochemical. So hexatriene means 3 pi bond will be there. So 6 pi electrons, right? So 3, this is psi 3, psi 2, then psi 1. But here they have mentioned it as photochemical condition. Then one electron will get excited, right? So it will move on to the psi 4, right? So psi 4 is our HOMO. Okay, psi 4 is our HOMO. Then if psi 4 is the HOMO, how many nodes will be there? 3 nodes, right? N-1 formula. 3 nodes. If you find out this, then the question is very simple. Just look at the answers. You have to find out in which option it has 3 nodes. Okay, see here, first of all, I have told you, right, opposite charges, between opposite charges there will be a node. Here there will be a node, and these are all same, right? Same lobes. We have denoted the lobes as plus and minus, right? Plus and minus. But here they have shaded portion and unshaded one. Okay, so shaded one has a charge and unshaded part has opposite charges. So between two opposite charges there will be a node. Here all the nodes are same, sorry, all the lobes are same, right? Then between these two, these are different, so between them there will be a node. So it has only 2 nodes, but actually we want 3 nodes, right? So this is not the option. Then see here, these two are same, so no node between them. These two are different, so between them there will be a node. Then these two are same, and here there will be a node, right? So 2 nodes. Again, this also contains 2 nodes, so this is not the answer. And see here, there is a single node, right? Between these two only there is a node, one node. So here it is also not the option. But see the D option. Here there is a node, here there is a node, and here. Okay, so 3 nodes are there. Hence this is the right answer. Okay, it is very simple if you know the concept. Okay, this is how you have to solve the question. First of all, you have to find out the which is HOMO. Then after finding out that psi 4 is the HOMO, then we have to calculate the nodes. N-1 is the formula, 3 nodes. Then just look at the options which has 3 nodes. Okay, that's the answer. It's very simple, right? Previous question was asked in CSIR December 2017. Okay, but now the second question, move on to the second question. It was asked in CSIR December 2013. Okay, very simple question. Just by saying itself you can find out the answer. Okay, the number of nodes present in the HOMO of 135 hexatriene at its ground state. Okay, first, what's ground state? See here, they haven't mentioned any condition. It is either in thermal or photochemical. They haven't mentioned. Okay, but they have given you the hint that in ground state. Okay, so when the electron will move to the excited state under photochemical condition. Okay, so hence here it is thermal condition. Okay, it is thermal condition. It is very simple, right? Hexatriene has 6 pi electrons. So 6 pi electron means 2, 4, 6. Hence psi 3 is the HOMO. Okay, psi 3 is the HOMO because they have asked in ground state. Okay, hence psi 3 is the HOMO. If psi 3 is the HOMO, the number of nodes N-1 formula. If 3, then N-1 is equal to 2. So 2 nodes. B is the option. Okay, very simple, right? Okay, the next question. This question has been asked in CSIR December 2013. Okay, so the number of pi electrons participating and the pericyclic mode in the following reaction is. See, you have to very careful, okay, while reading the question. And see here, they have given in thermal condition. Okay, first thing you have to note whether it is thermal or photochemical. Here it is thermal condition. Then number of pi electrons involved and the pericyclic mode. Okay, so here just see, it has 2 ways. Okay, first of all, you see the configuration in the reactant. It is cis or trans. It is cis, right? Because see here, all the hydrogens will be like this. So it is cis. Overall, the reactant is cis configuration. Okay. So here it is thermal. If 4 pi electron thermal condition conrotatory. Conrotatory means you have to change the stereochemistry. But suppose 6 pi electrons means it is disrotation. Okay. Now see here the reactant is cis configuration. Now look at the product. The product is also in cis configuration, right? The two hydrogens. See the two hydrogens both are above the plane. Okay. So here also cis. So what happens here? The reactant also has this configuration, the product also has this configuration, which means stereochemistry hasn't changed. Stereochemistry was not changed, right? If stereochemistry was not changed means it is conrotation or disrotation. It is disrotation, right? Because conrotation means change the stereochemistry and disrotation means don't change the stereochemistry. Here the stereochemistry doesn't change, which means it is undergoing disrotation. Okay, disrotation. Simply by knowing this you can eliminate these two options. Okay, it is undergoing disrotation. First of all, see the configuration of the reactant and the product both has this configuration. Then the stereochemistry hasn't changed, which means it is undergoing disrotation. Okay, then thermal condition. Under thermal condition, whether 4 pi electrons will undergo disrotation or 6 pi electrons will undergo disrotation. It is 6 pi electrons, correct? So 6 pi electrons under thermal condition will undergo disrotation, which means the option is D. Very simple, right? This is how you have to solve the problem. Okay, here the similar type of question. Okay, it was asked in CSIR December 2011. Same question. See here, in thermal condition, see the reactant, it is cis configuration, right? It is in cis configuration. And now see the product, it is also in cis configuration, which means stereochemistry doesn't change, which means the particular rotation is disrotation. Okay, it is undergoing disrotation. So you can eliminate these two. Okay, next. If it is undergoing disrotation in presence of thermal condition, 4 pi or 6 pi, which will undergo disrotation in presence of thermal condition? It is 6 pi. 6 pi thermal disrotation, 4 pi thermal conrotation. So option is A. 6 pi electrons under thermal condition will undergo disrotation. Okay, what you have to do, just see the reactant and the product both have same configuration. This means it is undergoing disrotation, and if the disrotation in presence of thermal condition, 6 pi electrons will undergo disrotation. Okay, hence the option is A. If you like this video, then please subscribe and share with your friends. Stay tuned. Thank you so much for watching.